I'll just read it. It says, so fluoride enters a region's groundwater when rain dissolves fluoride-bearing minerals in the soil. Okay, so what's happening? Rain falls. You have fluoride-bearing minerals in the soil, and they get dissolved, right? And then you have fluoride that then enters the groundwater. We're visualizing this. We have the soil, and then we have the groundwater underneath, and it rains, and then the fluoride comes into the groundwater. Sound good? Okay. In a recent study, researchers found that when rainfall, concentrations of fluoride-bearing minerals and other relevant variables are held constant, fluoride concentrations in groundwater are significantly higher in areas where groundwater also contains concentrations of sodium. Oh, okay. So fluoride goes up when what happens?
Sodium is present.
Yep, when there's more salt in the ground, right? In areas where the ground... Oh, no, sorry, not in the ground. When there's more salt here, in the groundwater. Right? In areas where the groundwater also contains a high concentration of sodium. Okay. So, if all these things are being held constant, except for the salt, and the fluoride goes up, what do you think? Is this an argument, by the way? No? It's just like fact. This sounds like what kind of fact, though? This is a certain kind of fact.
Causal correlation?
It's correlation, right? It's not causal, it's correlation. It says, hey, when you have higher levels of sodium, you have higher levels of fluoride. Okay. That doesn't necessarily mean that the salt is causing the fluoride to increase, but it could be, right? Okay. Which of the following can be most reasonably concluded on the basis of the findings? What kind of question is this? Inference, which means we are looking for an answer that is weak, that must be true given what was said, right? Or at least most supported. All right, let's go through them. A, fluoride-bearing minerals are not the primary source of fluoride found in groundwater. They might be the primary source, even though there's more when there's salt. Are we cool with that? Anyone tempted by this one? JJ?
No.
Okay. I would get rid of it because of primary. B, rainfall does not affect fluoride concentrations in groundwater. What? It's the opposite of what was said.
I put that one.
Wait. Do you still think this is right?
No, but I don't think it's the worst choice. Even though it looks like the worst.
Wait, they said that
Why?
fluoride enters the region's groundwater when rain dissolves fluoride-bearing minerals. So rainfall does seem to have an effect.
I kind of read it as like, now I see that I didn't read it exactly for what they said.
You thought salt was the only key factor?
No. I was like the distinguishing factor.
Yeah.
I was reading it as like the rainfall isn't what is affecting the change of fluoride. Like, because they gave two situations and rainfall is held constant, then I was like, yeah, the rainfall isn't what's affecting the fluoride concentration.
That's the key though, right? When rainfall is held constant, then salt makes a difference. But when rainfall is not held constant, fluoride could be going up and down.
Yeah.
Are we cool with that?
Yeah.
Okay.
No, I know that it's wrong.
Oh, okay. Cool. C, sodium-bearing minerals dissolve at a faster rate than fluoride-bearing minerals? Do we know about sodium-bearing minerals? Nope. Out. D, sodium in the groundwater increases the rate at which fluoride-bearing minerals dissolve. Well, if that's true, if the sodium in groundwater, well, not if it's true, that seems like it could be true, though. That could be consistent with the data, right? I would definitely keep this one open. You guys keep this one open? Okay. Soil that contains high concentrations of sodium-bearing minerals also contain high concentrations of fluoride-bearing minerals. I'm guessing this is the one we were debating. This is what we're debating?
Yeah.
Okay, so tell me this. What's the difference between D and E?
It's in the soil as opposed to the water.
Yes. And this is actually one of the things that we talked about initially. Remember I put the salt up here and I was like, oh wait, oops, they talked about the salt down here.
Mm-hmm.
So that reading is actually kind of significant. I don't know if we know anything about soil that contains sodium. We only know about groundwater that contains sodium. So I would go with D. Did we catch that difference, or did we think these are pretty much the same? We saw the difference.
Yeah.
All right. So who wanted to talk about this question? All right. Are you guys debating E? Do you feel good with it now? So why do you think you guys missed it before?
I didn't see the soil.
Didn't see soil.
I think what screwed me up was sodium in groundwater. So the sodium in the water increases the weight at which the fluoride-bearing minerals, which are in the soil, dissolve.
Yeah, you're like, how is that possible?
Yeah.
Yeah, I don't know. But that's what the fact said, right? The fact said when you have more sodium in the groundwater, then you have greater concentrations of fluoride.
Right, so I thought it was the opposite way around.
You thought, oh, and that's why you thought E?
Yeah.
You thought the salt must be in the soil?
Yeah.
Yeah. Yeah, it's confusing, but that's what the fact said. I don't know what's going on. All right. Cool. Any other questions on that one?